Welcome back to another video of my channel, math_exe. Today we're going to look at more examples of linear inequalities and some contain word problems. So for question 1 is pretty standard and we need to solve each following inequality. So we have 3 of these and we need to find the greatest or smallest depending on the inequalities on each case. So greatest or smallest integer that satisfies each of these inequalities after we solve them. Alright, so let's just start off with question A, which is a half of x minus a quarter times x minus 5 is greater than or equal to 1. Well, what I would like to do is to multiply 4 on both sides, just so that we can remove the denominator very nicely. So when you multiply by 4, this 2 and this 4 will cancel, leaving us with 2 on the numerator right there. So it will be 2x. And then a quarter times 4 will cancel out nicely, so we have in brackets x minus 5. And don't forget to keep the brackets when you're doing decimal stuff. And of course 1 times 4 is just 4. And from here we can just expand these brackets. So we have 2x minus x plus 5 is greater than or equal to 4. So we have x is greater than or equal to, well, you can just subtract 5 from both sides, so we get negative 1. Alright, so that's our inequality solved, and then we need to find the greatest or smallest integer of this inequality. Well, in this case, since it is a greater than or equal to sign, we will need to find the smallest integer. So the smallest integer in this case will be negative 1. So notice the solutions of these will be like negative 1 and 0 and so on, like that. And then you also need to consider the rational and irrational numbers between negative 1 and 0. So the smallest integer that satisfies this will be negative 1. So that's part A done. Let's just jump into part B, which is 3 times x plus 2 minus 4 times 3 minus 2 times x minus 2 is less than 1. So first of all, we can just expand the brackets here. So we have 3x plus 6 minus 4. We'll keep the larger brackets first and just simplify the inside the big brackets. So we have negative 2x plus 4 is less than 1. And afterwards we can just expand what is inside the big brackets. So it will be negative 12 plus 8x minus 16 is less than 1. And from here we can just group like terms. So we have 11x, grouping this and this, and then grouping the constant terms, you'll get negative 22 is less than 1. Adding 22 on both sides, and then afterwards dividing both sides by 11. So you get 23 over 11. And for the greatest or smallest integer in this case, since it is a less than or equal to sign, we will need to find the greatest integer. So notice if you go downwards from 23 over 11, you notice the first integer that you meet when you go downwards from 23 over 11 will be 2. And that's pretty easy to see if you are plugging that back into the inequality and stuff like that. So the final part of this question, part C, is 5 times p minus 3. Well, actually, I'm just going to rewrite this. So I have p plus 1 over 2 plus a quarter p is less than 2 over 3. Well, we can expand what it is inside of this bracket. So you'll get 5 times in brackets p minus 3p minus 3 over 2, and then just rewrite all the remaining stuff out. And then from here we can just expand what is inside the brackets, and then afterwards group like terms. You get negative 10p minus 15 over 2 plus a quarter times p. And we can multiply by 4 on both sides to get rid of the denominator of both expressions. Well, I should say both fractions. So this will be negative 20p minus 30 plus p is less than 2 over 3. And you can just add and subtract stuff out to get negative 19p is less than 98 over 3, and you'll get that p is actually greater than negative 98 over 57. And for the greatest or smallest integer, since this is a greater than sign, we need to find the smallest integer. And the smallest integer of this inequality will be negative 1. So you can pretty see that easily if you plug in negative 1 as p, it will satisfy the inequality. Alright, so that is the entirety of question 1. So for question 2, this is a word problem type question. So Andy buys a certain number of oranges and apples. He wants to pay for at most $20. And the keyword here is at most, and that will be very handy for later. The cost of each orange is $0.20, and the cost of each apple is $0.30. Let x and y be the number of oranges and apples Andy buys respectively. So for part A, we need to set up an inequality in terms of x and y for the possible total costs of the oranges and apples. So since we know x is the number of oranges and the cost of each orange is $0.2, that means the total cost for the oranges that Andy will buy is 0.20x dollars. And then you add it by the total cost for the apples, which is pretty much a similar thing. So we have 0.30y dollars. And the keyword here is at most. So at most is it could be exactly $20, it could be less than $20, but it can never be greater than $20. So for the inequality sign, the correct inequality sign for this problem is the less than or equal to sign. And here we have $20. Alright, so that's the inequality setup. So for part B, assume Andy buys the same number of oranges and apples. So from here, we can just set x to be equal to y. Solve the inequality and find the maximum possible number of oranges he could buy. Alright, so I'm just going to use x for this inequality, and I'm just going to plug x into the inequality set it up. So you'll end up something like this. And from here we can just neglect the dollar signs. And here we can just group like terms for the x terms. And from here you can just say that x is less than or equal to 40. And that's the inequality solved. And we need to find the maximum possible number of oranges he could buy, which is the maximum integer or the greatest integer solution of this problem. And why is it greatest integer? Well, it is greatest because the sign is a less than or equal to sign, so therefore it must be the opposite. And it is an integer because, well, it theoretically wouldn't make sense if you have like a half of an apple in the store, or possibly a square root of 2 of an apple for store. That makes even less sense. So that's why we must choose an integer in this case. And the greatest integer in this case, it will be 40. So this is the maximum value of x, which is the maximum number of oranges that Andy could buy if he wants to pay for at most $20. Alright, so that's question 2 done. Let's jump into the third question. Question 3 is strongly related to number patterns and sequences. So given a sequence 2, 5, 8, 11, 14, 17, and you can quickly notice that that sequence is an arithmetic sequence with difference 3. So from part A, the nth term of this arithmetic sequence will be the first term, which is 2, plus n minus 1 times the difference, which is 3, which will give us 3n minus 1. And for part B, this is pretty interesting. We need to find the largest 3-digit number that lies on the sequence. So that's the first part of part B. So, well, if you want to do this question for yourself, I would suggest that a tip is that 999 is the largest 3-digit number. So you can use that for your advantage. However, I'll just jump into the solution for this one. So since we know that 999 is the largest 3-digit number, well, for this thing right here, this number to be the largest 3-digit number possible, we need it to be, we can just form an equality that this number must be less than or equal to 999, which is the largest 3-digit number. And then solving this inequality, you get n is less than or equal to 333. So it is this number right there. And from here, we can just find the greatest integer solution for n, since we want to find the largest 3-digit number, which is when n is equal to 333. And with this is just only the term number of when the number is largest, when the number is the largest 3-digit number. So therefore, with this number, we can just substitute this back into this equation, and you get the nth term, which is the largest 3-digit number that lies on this sequence, will be 998. And likewise, you can just do this for the second part, which is the smallest 4-digit number. And we can also notice that 1000 is the smallest 4-digit number. So again, we can just set up an equality, but in this time, greater than or equal to 1,000, and you get a solution of 333 and 2/3, which will give us the in this case the smallest solution of this inequality to be 334, and therefore we can just plug in back to our formula for the nth term of the sequence to get the smallest 4-digit number that lies on this sequence will be 1001. And for this third part, we need to find the number that lies on the sequence that is closest to 2022. Alright, when I say it is closest to 2022, it could mean two different things. Meaning that number could be less than or equal to 2022, or that number is greater than or equal to 2022. And with these, we need to find the greatest and smallest integer solutions respectively, and then just compare them and see which one is the closest one to 2022. And I'll just quickly say things up. Long story short, the solution for these inequalities will be 674 and the third. Likewise, this will stay the same. And here we need to find the greatest integer solution, which is 674. The smallest integer solution for this inequality will be 675. And substituting the value of n to the formula for the nth term of the sequence, you'll get for this case you'll get 2021, and for the second case you'll get 2024. And if you compare 2021, 2024, and 2022, which one is the closest one? Well, 2021 is the closest one because the difference between 2021 and 2022 will be 1, while the difference between 2022 and 2024 will be 2. Very close difference, however, 2021 is the winner. So that's it for question 3. Let's jump into question 4. For question 4, the following table shows the cost for a ticket per person for the premium circus show regarding age. So we have 3 age categories and we have the price per ticket per person. So for adults that are 21 years old, for adults that are older than 21 years old, the price per ticket per person will be $20. For children between 4 and 21 years old, the cost will be $16. And for infants less than 4-year-olds, the circus doesn't charge any price at all. So from this information for the age categories, we need to solve these following questions. A school wants to pay $200 for several tickets for their children. What is the maximum number of children that can watch the circus? Well, we need to suppose a variable. Let the number of children be x. So from here we can just form an inequality in terms of x regarding the price of the tickets and how much the school needs to pay for that, which will be $16 times x is less than or equal to $200. And you say, how did I get $16 here? Note that the price per ticket per person for children is $16. So you can just multiply that by the number of children. And for the $200, it's the amount of money the school wants to pay. Solving this inequality, you'll get x is less than or equal to 12.5. And from here we can just find the greatest integer solution of this inequality. This will give us x equals 12. So the maximum number of children that can watch the circus is 12. And for part B, a family with 3 adults, 4 kids, and 1 infant want to watch the circus. What is the minimum number of $10 bills to pay for all the tickets? Well, we can suppose another variable. Let the number of $10 bills be, let's say, A. So we can just form an inequality regarding the total cost of the tickets and the number of $10 bills and the total money that needs to be paid for. So we have 3 adults, and we know that the cost of per ticket per person for adults is $20 plus 4 kids, and we know the price per ticket per person for children will be $16, and for infants the circus does not charge any price at all for the tickets. And this price must be less than or equal to the price that is need to be paid for, which is the total price, the total payment for the $10 bills, which will be 10 times $8. Well, we get 10 because that's the value for one $10 bill, and we get A for the we get A because we suppose that the number of $10 bills is A, and thus we can solve this inequality. Notice the left hand side will simplify to $124. Solving this inequality, you get A is greater than or equal to 12.4, and finding the greatest integer solution for this, not the greatest, the smallest integer solution in this case, since is a greater than or equal to sign. So the smallest integer solution for this will be 13. And why integer? Well, it won't make sense if you have half a $10 bill. Well, suppose you have a $10 bill and you cut it in half. Or if you have a pi of a $10 bill, that makes even less sense. So we're supposing that the number of dollar bills is an integer, so we suppose that A is equal to 13. So the minimum number of $10 bills to pay for all the tickets is 13. Alright, so that's question 4. It's jumping to question 5, which is, well, it's probably unrelated to linear inequalities, but it's still about inequalities, but in a different way. And in that different way, observing the graph of functions. So let's just jump into question 5. For the 5th question and last question, it's about observing the graph of functions, and then make some inequalities about it, and stuff like that. So for part A, the graph below shows two functions f of x and g of x. And perhaps I should have added that f, f of x and g of x are meant to be linear functions. So as you can see, there are meant to be straight lines, and they intersect each other at x equals 6. So write down inequality in terms of x that shows that f of x is greater than g of x. In other words, f of x is above g of x. So as you can see, it is at these parts right here, and these parts are on the left side of 6, which means the x inputs must be less than 6. So for part 1 of part A, the right inequality is as x is less than 6. And we need to also write down the inequality in terms of x that shows that f of x is less than g of x. Okay? In other words, f of x is below g of x, or I should have said that the output of f of x is less than the output of g of x. And as you can see, it is in these regions, and it goes towards infinity. Alright, and since it is on the right side of x equals 6, the right inequality will be x is greater than 6. Alright. And perhaps I will just add a bonus point. We need to write down an inequality or equation in terms of x that shows that f of x equals g of x. That means the outputs of f of x and g of x are equal. And from the graph we know that x is equal to 6. Since they intersect at x equals 6, therefore their y outputs must be the same. So part 3 of part A is just a bonus, just to point that out. So anyways, part B, the following graph shows two other functions, u of x and v of x. So as you can see, they intersect each other at -3 and 12. And for part A, we need to write down one or more inequalities in terms of x that shows that u of x is greater than v of x. In other words, the output of u of x is greater than the output of v of x, or u of x is above v of x, which are these regions right here, the left side of -3 and the right side of 12. Well, from that, the right inequality will be x is less than -3 and x is greater than 12. And for part 2, we need to write down one or more inequalities in terms of x that shows that u of x is less than v of x. Alright, and in other words, that u of x is less than v of x is that the output of u of x is less than the output of v of x, or v of x is above u of x, which are these regions marked in blue. So it's between -2 and 12. So from that information, the right inequality is -3 is less than x and it is less than 12. So those are the bounds of where u of x is less than v of x. And perhaps I'll just add a bonus question yet again. We need to write down one or more inequalities or perhaps equations in terms of x that shows that u of x is equal to v of x. In other words, the outputs of v of x and u of x are equal, which is also the points of intersection of both functions, which are at -3 and 12. So the right in equations are x equals 3 and x equals 12. Well, sorry, not 3, is -3. Alright, so that's it for question 5 and the whole point of this video. So hope you guys enjoyed this video, so please subscribe and leave a like, and probably suggest what problems or what topics should I do next, because I would really like to hear about your comments. Anyways, goodbye.